Hello once again to Special Maths Academy, and in today's video I'm going to be covering one of the questions from the just concluded Senior First Round Maths Olympiad 2020, Nigeria. So this is problem 10 and it goes like this. If y is the product of the logarithm of some numbers, as you can see on the screen, then find the value of the product or find the interval where y occurs. So this is a logarithm question. A logarithm has a lot of properties, but the most helpful property in solving this question will be this one. I'll just write it down. It's not one of the most popular properties of logarithm, but we should always have it at the back of our minds whenever we see logarithms being multiplied directly, because we can't really multiply logarithms directly. We can only add them to have the same base. But when they are multiplied repeatedly, yeah, this is a good property to look out for. So when you have, let's say we have three positive real numbers. Remember, the most positive real numbers, and we have that log b base a is equals to this change of base. That's how it's called, property change of base. You want to read it up. So this is also equals to this, where c is any other arbitrary real number. Like c has no special properties, just any other positive real number. Yeah, so this is what will be really helpful for us solving this question. So I'm actually going to prove this property in this question before we use it here. So the proof is not so difficult. We just how logarithm and indices, they work hand in hand. We can convert a logarithm equation into an indices equation and vice versa. So that is just how the idea we use in solving this question. So we're just going to say let log, this is what we want to prove. So we don't have this required to prove RTP. This is what I want to prove. Let's say log a base b, let's say is equals to x. Log c base b, let's say is equals to y. Log c base a, let's say is equals to z. So somehow we want to prove that x is equals to y over z. So now from this first equation here, this one I'm underlining now in red. Yeah, this one here. These are a logarithm equation. So to convert it to an indices equation, we can go okay, let me just write it here again. It implies, or it's actually if and only if b is equals to a raised to power x. And similarly, log b base c is equals to y if and only if a is equals to c raised to power y. And log a base c is equals to z. Log a base c is equals to z if and only if a is equals to c raised to power z. So what we're going to try to do now is we're just going to play around with these three equations. For example, b occurs here and here. So we're going to substitute the value of a of x into here and then substitute. So just try and do some substitutions within these three equations. So how I'm going to approach it now is that I'll replace b with a raised by x in this second equation. Let's call this equation 2. Equation 1. Equation 3. I'm going to replace b with a raised by x in the second equation. So what are we going to get? We're going to get that a raised by x is equals to what? C raised by y. So, and we also have this third equation, a is equals to c raised by z. And this first equation, b is equals to a raised by x. So the next thing I'm going to do now is a is equals to a is equals to c raised by z. So I'm going to replace a with c raised by z into the second equation. The second equation is the place we'll be substituting the first and third equation into. So a is equals to c raised by z. I'll replace a with c raised by z into the second equation. And what are we going to get? I'm going to get that c raised to power z, the new value of a raised to power x, is equals to c raised by y. And by the laws of indices, when we have two powers, the power and again another power, the final result is going to be product of the two powers. So how that c raised by zx equals to c raised by y. And because c is a positive real number, remember, we can, when we have something like this, if we have a function, maybe f of x equals to c raised by x, where c is a positive real number, it's not difficult to show that the function is either strictly increasing or strictly decreasing. So it's basically injective. So because of the fact it's injective, we can easily conclude that the two powers have to be the same. So what does that mean? So that gives us that zx equals to y. So zx equals to y now. So that means x is equals to y over z. Recall this is what we wanted to prove. X is equals to this log b base a, y is equals to this over z is equals to this. So that is basically what we wanted to prove. And we use indices to prove it because we are more like familiar. Generally, we're more familiar with manipulations using indices. So that's why I'll change the logarithm equation to indices equation. So this is the proof of this. Remember, it's a very, very important property of logarithm that I should keep in mind, especially when we have things like this, when logs are being multiplied. Really, really helpful many times. So from there, we're almost done with the question from that simple observation. So how are we going to finish the question up? I'm just cleaning this out. And clean this required to prove. So now, see how we do it now. So let's write down the question log 2 base 3 times log 3 base 4. If you notice, these numbers are consecutive times log 4 base 5 dot log 63 to log 64. So applying this property here, we can say that this equals log 3 over log 2. Actually, we can choose any base we want, but just for without loss of general, let's just choose log 10. This 10. It doesn't really matter the base we choose, because as you remember, C was arbitrary. So this first term is equals to this second term, then we should now be consistent. Since we chose 10 in this first time, let's just choose 10 in all of them. So like some terms that can start cancel out. Because if we chose another base here, we won't have been able to cancel this out. So that's why we'll just be consistent with our original choice. So we keep on going till, I didn't write this way, sorry. 64. So keep on going to log 64 base 10 over log 10, 63. So this is the idea, like this is the necessary, this thing was important that these numbers are consecutive. So this we cancel out this we cancel out to this we cancel out this, and we can keep on the pattern. Second to last term here will be log 63 base 10 over log 62 base 10. So log 63 on the numerator cancel out this. I'll just be left with the first numerator and the first denominator and the last numerator. So that will be log 10, 64 over log 10, 2. And we can then work from this right hand side here, go back to the left hand side. So what will this give us? This will give us log 2, 64. 64 is 2 raised by 6. So we can easily conclude that this log 2 raised by 6, 2. So this is 6. So the answer to this is 6. That is the value of y. So it implies that y is equals to 6. And that is answer 6. At first may have looked a bit strange because we have a lot of numbers here that we can't exactly find what they are. But when you multiply all of them together, we somehow get the whole number. The answer is 6. So this was just the lemma, the property that helped us to easily do this question, and should be something we should keep at our fingertips for solving questions of this nature. So I think that's all for today, and I'll see you in the next video.